Okay, so in this video, I'm going to cover 3.4c, Transformations, Vertical Stretch Notes, and we're going to answer the essential question, how do I apply vertical stretches to a given function? So remember your vertex forms for both quadratic and absolute value. Remember where your h is, remember where your k is, right? But what becomes, and then remember where your a is. So when we did reflection, we were looking to see whether or not A was negative or positive, right? Because if it's negative, we're going to reflect it across the x-axis. But we're going to pay attention now to what is the size of the number of A. So remember, horizontal shifts left or right. Vertical shifts up or down, okay? So if you're positive, you're going to shift left. If you're negative, you're going to shift right on the H. That's in vertex form. K, if you're positive, you're going to shift up. You're negative, you're going to shift down. If A is negative, the function is reflected across the x-axis. But what happens if A, the absolute value of A, is greater than 1? This will be a vertical stretch. Okay. Transformations from the parent function are described below. So let's write the equation. So y equals x squared. So we're starting with a quadratic. Shifted 2 units right. How would we do that? Well, let's see. So let's do f of x equals, all right. They're using y here, which is f. I'm going to write it, well, I guess I'll write it as y. Don't be confused by that. It's f of x. Y and f of x are interchangeable. They're the same thing, okay? But because they're introducing it as y, I'll write y. Okay, so here we have our absolute value function that is shifted 5 up. So remember, in this one, they're providing us with an h. In this one, they're providing us with a k. So y equals absolute value of x shifted 3 units to the left and 4 units down. So now we have both an h and a k. So we start with your parent function. You put your h in, and you put your k in. We're going down, and we're going to the left. So remember, with your h, you have to think of it in the opposite way. X, and it shifted 4 units to the right, so it's going to be minus 7 squared plus 4. Now we're going to deal with a few reflections. So y equals x. It's going to be reflected over the x-axis, then shifted 3 units down. Okay? And you don't need the parentheses. Okay. All right. So y equals, we know it's going to be reflected. So we know it's shifting right, which would make it minus 5, and 2 units down, minus 2. All right, so vertically stretched by 3. Okay, so now that it's vertically stretched by 3, we know we have an A of 3. Then translated 8 up. Okay. Again here, it's reflected over the x-axis, vertically stretched by 2, and then it's going to be 4 units left, which would make it plus 4 squared. All right, so how would we handle vertical stretch? when a is greater than 1? So here is an example of the parent function, and then we'll do it with a stretch. Okay? So here our h equals 0 and our k equals 0. So we'll put our vertex in there right in the middle. And then here we're going to have -1, -2. We're going to have 1 and 2. Okay. Same with here, right? Our h equals 0 and our k equals 0. So 0, 0. We're going to have -1, -2, 1, and 2. Okay, so we're going to put, so what happens when we put 1 in there? Well, it's 1. What happens when we put 2 in there? It is 4. Same here, same here. All right, but what happens when y equals 4x squared? Well, we're going to do 4 times 1 squared, so we get 4. Here, we're going to get 4 times 2 squared, which is going to give us 16. We're going to have our 4 and our 16 here. So let's look at a transformation. So unlike when we do a vertical or a horizontal shift or reflection, when we draw our vertical stretch, you're going to have to set up your table of values first. So figure out your vertex. So we know that h equals 0 and k equals 0 in this example because we don't have an h here and we don't have a k after that. So put your 0, 0 in there. Then you know you're going to do -1, 2, 1, and 2. So let's put our values in there. 2 times 1 squared. Well, we're going to end up with 2. 2 times 2 squared. End up with 8. And we're going to end up with those same numbers here. So let's plot them. Well, we're going to stay at 0, 0. And then here, we're going to be at 2. And here, we're going to be at, then we're going to go all the way up to 8. So what you're going to find out is the greater the number, the closer your function is going to get to the y-axis. So our y, so our transformation is stretched by 2, okay? All right, so let's look at this next one. So again, our h is 0 and our k is 0. They're not present in our function. So put them right there in the middle. You're going to have your -1, your -2, your 1 and 2. So now let's put it in our function. It's the absolute value of 1. So we're going to end up with 3 here. What about with the absolute value of 2? We're going to end up with 6 here. Same here and same here. So our function should be moving closer to our y-axis. So our vertex stays the same. But at 1 and -1, we're going to be up at 3. Okay? And then at -2 and 2, we're going to be up at 6. Okay, this one is a V. So when we stretched it, we moved it closer to the y-axis. All right, I'm going to do one more, and then you can work on the last one. So our h is 0, but our k is -3. So we're going to have 0, -3 here. We're still going to do the -1, 2, and the 1 and 2. So let's put this into our function. So we're going to put 1 in there. So that's 4 minus 3. We're going to be at 1. Let's put 2 in there. So 8 minus 3, we're going to be at 5. So we're going to get the same answers there. Okay, so let's graph it. So we are going to be at 0, -3 now. 1, 2, 3. Okay. And at 1 and -1, we're going to still be at 1. We're going to still be at that same point there. And then at 2, -2, we're going to be up at 5. So that's our, okay. So unlike the first two, because we had a stretch with our k, well, we stretched it with our a, but we also shifted down. So that's why we ended up here. Okay. So we shifted down. I'm going to write the stretched first. So first we stretched. Whoops. By 4, by a factor of 4, and then we shifted down 3. Okay. Now you try this last one. Please come to me if you have any questions.